All right. Hello, everybody out there in internet land, and welcome to the second in our Wiki Research webinar series, Becoming Wikimetrics. Today, we are going to talk about, I'm Jonathan Morgan. I'm from the Grant-Making, Learning, and Evaluation team at the Wikimedia Foundation. And today, we're going to do some work in depth on using MySQL to get data from the Wikipedia databases and databases for other Wikimedia projects, and explore what's happening in our projects. So the purpose of these sessions is primarily to demystify the fact this process of doing research and doing quantitative research and programming to provide a starting point for you, whoever you are out there, presumably someone interested in asking and answering questions about what's happening on Wikimedia projects, to provide you a starting point to do your own independent work. And in this session, we're going to talk about one of the most powerful tools for doing that kind of work on Wikimedia projects, a programming language called MySQL. So we're going to start with a quick refresher of some of the information I covered in the last session, which happened about a month ago, on what MySQL is and what it's for. Then I'm going to introduce Quarry, which is a new tool that someone in our movement has created to make it a lot easier for normal folks like you and me to use MySQL for research. Then we're actually going to start running queries and getting data. This is the fly by the seat of your pants part of the presentation, where we hope that I remember how to write MySQL and that everything works like it should. Then I'm going to throw out a couple of fun challenges for you to work on if you're interested before the next session. And then I'm going to describe a little bit of what we're going to do in the next session, which is going to happen next Wednesday at this same time. And during the course of the presentation, if you have questions for me or general questions about how to do stuff with MySQL, if something goes wrong or if you're confused by something that I'm saying, you can go to the Q&A board on the Google Events page where you're watching this, or you can go to the Wikimedia Research channel on IRC, and mentors are standing by there at that channel. So, what is MySQL? MySQL stands for Structured Query Language, and it's a language for writing queries, which are questions, or commands that let you request certain kinds of data from a database in a way that the database can understand, and in a way that's also relatively easy for humans to understand, although it takes a little practice. So this is reviews from last time. Here's a sample query. Select a page title from this table in this database where that page has been touched, which usually means edited, sometime today. So the translation in person speak is, computer, give me the names of all the Wikipedia pages that have been edited today. So the databases that we have available to us, made available on wmflabs.org, include almost every act that on every Wikimedia project that results in an edit, and then particular information about that edit, who made it, when they made it, what pages they made it to, how big it was, etc. We also have information about the relationships between pages. For instance, which pages link to each other, which pages are in what categories, what templates are transcluded on pages. And there's also some tables in the database that contain event logs. So events that happen that aren't necessarily edit related, like when a new user registers an account, when someone's given a different user right, say somebody becomes an administrator or a rollbacker, and also events like the locking of pages, locking of editors, etc. So why is this presentation called Becoming Wikimetrics? This is all part of this idea of trying to demystify what programming is and what research is. So Wikimetrics is a great tool that the analytics team at the Wikimedia Foundation has developed, which makes it easy to take a list of usernames or user IDs and find out information about those users' editing behaviors online, which pages they've created, edited, how many edits they've made, etc. Wikimetrics does this by doing what we're going to be doing today. It creates a MySQL query based on the boxes you click and the usernames you upload, and it queries the database. So if you learn how to use MySQL, you can do exactly what Wikimetrics does. And in fact, you can do even more than what Wikimetrics does. So again, reviewing from last session, why do we want to use MySQL versus the Wikimedia API, which is another tool that we talked about last time for getting data about what's happening on wikis. MySQL is great because it allows you to request lots of data. Give me every edit by every new user from the last 5 days. It also lets you be very specific about the kind of data you want. So you can say, I want all these edits by all these people, but to these pages, but not to these pages, and not by these people. And it makes it easy to dump your data into, say, a comma-separated value file, which is a great format for you to play with in a spreadsheet program. And last time I said, if you have a WMF Labs account, you can get started using MySQL. Fortunately, you no longer need to have a WMF Labs account, which is great because it's kind of difficult to get one, just in terms of the number of steps that it takes. And the reason why you don't have to have a MySQL account anymore is because of one of our contributors, user UVPanda. After the last session, I was talking to him on IRC and said something along the lines of, wouldn't it be nice if we had a public interface, a web page, where people could write MySQL queries and they could get data back from them without having to go through all the hoops of creating a Labs account. And so UVPanda just created this. It's a tool called Quarry, and I'll show you it in just a second. But it's something that I'm very excited about, and it's the tool that we're actually going to be using today to demo. So let me really quickly switch my screen to Quarry so I can walk through the tool with you, and then we'll get started with the introduction to MySQL, and we can start running some queries. Hi everybody, this is me, in case you didn't remember me from last time. So you can go to quarry.wmflabs.org to see the page. And there it is. All right, and now you should be seeing it here too. So let me go to the main page of Quarry. So this is Quarry. It is in beta. So if things are a little rough around the edges, be patient, and it will be figured out. The way you access Quarry, the screen you'll be seeing if you've never seen it, if you've never been here before, it asks you to log in with your Wikimedia account. So you click log in, then it redirects you to Meta, and a little pop-up says, SQL Quarry would like to have basic access on your behalf to meta.wikimedia.org. You say allow. We are not going to use your user data for nefarious purposes or sell it to advertisers. And now, if you're in Quarry, you'll see that you're logged in with your Meta account, and there are a couple of options across the top. You can look at your recent queries, you can start a new query, or you can go to the Quarry homepage. So if you go to, and you can also go to your profile, which contains a list of the queries that you've run on Quarry, and it shows them sequentially, and it also shows ones that you've run and that you have published, which makes them show up in a separate list. And this helps you keep track of the queries that you want to save and run again, or that you might want to share with other people. So the query interface looks like this. If I create a new query, it's blank here, and I can say my first query, and I can write MySQL here. This is a MySQL statement, and I'm asking for a single revision from English Wikipedia that was done by user JT Morgan. And now I'm running my query, and it shows a revert that I made using Twinkle. Gosh, I'm such a nice editor. So that's the basic process. And if you'd like to publish your query and make it show up in your publish list, you click Publish, and you can describe your query. And that makes it easier for other people, since all the queries you make on Quarry are visible to other people. They can go to this URL across the top, and they can see the query that you made. This gives people some idea of what you actually did. So speaking of what you actually did, let's go back to our presentation and talk a little bit more about MySQL. Pardon me while I do the window switching dance again. All right, and we're live. So, first we're going to talk a little bit about some concepts from MySQL, and particularly how the databases of Wikimedia data are organized. And then we're going to go through some examples of how to write MySQL statements. So databases. Databases are big structures that are intended to hold data. And data is being created on our projects all the time. Every time anybody creates an account, every time anybody edits a wiki, that's a data point. And that information is stored in databases so that we can have features on our wikis, like looking at page histories, like comparing revisions of different pages. The databases store all the historical content of our wikis. The databases that we have access to are called replica databases, which basically means that everything that's happening on Wikipedia is being stored in a database, and that's called the production database. What we have are databases that are almost real-time copies of those production databases. So as new edits are coming in and being saved, there's a program that's frantically copying all that information to a second database. And what we're querying is this second database. So it has all of the public information that's being put onto Wikimedia databases, and it's almost live. So if I were to make an edit to a wiki right now and then query to find that edit, it would probably show up within a few seconds. But occasionally there's some lag. So it may be that I make an edit right now and then 5-10 minutes from now query to try to find it and it doesn't show up. For our purposes though, we're just going to assume that it's live.
Jonathan?
Yes, Maria, go ahead for it.
We have a question here. They are asking, is it possible to access using command line client like CURL? I think it refers to something that you were.
Sure. Yeah, you can definitely you can make requests to the API using CURL. I'm not sure that Quarry is set up to do that. That's a great question to ask on the IRC channel, where the creator of Quarry, UV Panda, is standing by. And there's a link to the IRC channel if you don't happen to have an IRC client. The channel is Wikimedia Research, and there's a link to the web interface, which allows you to ask questions without just through your browser at the Wiki Research webinar page. Yeah, and to all of you out there, please do continue to ask clarifying questions, and Maria will stop me yakking for a moment, and I'll try to address them. So these databases, there's one database per wiki. So there's one for English Wikipedia, there's one for Tagalog Wikisource, there's one for every wiki. And you can query, I believe, all of them. Although today we're going to be just using the English Wikipedia for simplicity's sake. There's a list of the different wikis that are available, and the way that you would specify, I want stuff from this wiki, is you would put a prefix in the query, and we'll talk a little bit about what that is and what that means. But the convention for it is generally the language code of the wiki plus the word wiki or Wikisource, Wiktionary, and then _p to denote that this is the public version, which means it doesn't contain information like the email addresses of registered users. Stuff like that isn't available publicly. And this query at the bottom of my slides, if you run that query in Quarry, you will see a list of these different names. There's a lot of tables in the databases. I have one table per content type. So there's a table for revisions, and that table has a line in it, has a row in it for every single revision that's ever been made to Wikipedia. There's a table for users, and that table has a row for every user in Wikipedia. There's a table for pages, a table for categories, etc. Each of these tables contains many rows, and each row contains many fields. And every wiki has one of these tables. So there's a revision table, a user table, a page table, a category table, etc. in all the wikis, which means that the kinds of queries you're writing today, when you're looking at these tables, will work whether you're exploring English Wikipedia or Tagalog Wikisource. There are also some special tables, and these aren't necessarily on all of the wikis. These tables are set up to track particular kinds of things. And some of them are updated and some of them are not. So one example that we'll be working with today is the WikiLove log table. And this table contains a row of data for every time anybody sends WikiLove. And I don't believe that WikiLove is implemented on every wiki, so you wouldn't necessarily see that table in all of them. And there's a query at the bottom here that queries that special WikiLove log table and shows you some recent WikiLove messages that have been sent on English Wikipedia. So in each database there are tables, in each table there are rows, and in each row there are fields. A field is like a cell in a spreadsheet. It contains some metadata about the row. So if the row is information about a user, a field might be username or user ID or user registration date. These different fields contain different types of data. So some of them are numbers, some of them are timestamps, some of them are strings of text like edit comments. So table keys are kind of the magic thing about databases like that use the MySQL language. They're called relational databases, which means that even though pages are in the page table and revisions are in the revision table, there are some fields that contain the same data between those tables. So if you want to find all the revisions to a page, there's in the revision table, there's a rev page field for every line, which means that for every revision, we capture what page that revision was made to. And in the page table, there's a page ID field, which gives each page, each line in that table, its own numeric ID. And
Jonathan?
Yeah, go ahead, Maria.
And a new question. Is there a list of tables and special tables?
Yes. So in the, let's see. So this query on this page here, all tables in the English Wikipedia database, if you go to, let's just go there now. I have to do my little screen share dance, but we can deal with that. Lamb. So if we go to My Queries, we'll go to the All Queries in the ENWiki database table. And this is a MySQL command, which is pretty straightforward. It says show tables from ENWiki, which is the name of the ENWiki database. And you'll see it's returned 108 rows. And each of these lines here, each of these rows, contains one field. And that field is just the name of the table. So you see a lot of these tables, AFT means Article Feedback Tool, which is no longer enabled on English Wikipedia. So these tables won't be updated. But tables like the category table or the page table are standard tables that will be everywhere. All right, back we go. All right, so fields, databases, tables, rows, that's the basics. And this is stuff that you'll need to become familiar with, but you can start running queries before you understand everything completely. It's something that you can kind of learn as you go. But those are the basic concepts. That's how the data are organized in our Wikimedia databases. So keys let you join tables to another. So the rev page field in the revision table is going to have a number in it, and that number is going to match a number in the page table, which means that that revision was made to that page. That lets you join tables together and get interesting results. So speaking of joining, let's talk a little bit about the basic syntax of MySQL. So I just talked about joining tables. So if I wanted to say find out the registration date of every editor who edited Wikipedia on the 25th of January in 2002, I would need to pull data from two tables, the user table and the revision table. The user table contains information about a user, so their username, their registration date, their current edit count, etc. The revision table contains every single edit, and it contains the timestamp of that edit, the date that edit was made. So I need to join these two pieces of information together. So if we look at this query, current edit counts of ancient editors. So we're actually getting there. This will give us the username, the registration date, and the edit count, and the timestamp of an edit for users who edited on the 25th of January in 2002. So let's just submit this query again and see what happens. So I've edited the query. I added a new request, a new column to it. I wanted to get the registration date as well as the edit count and the timestamp. And my query is completed, and you can see that it pulled out 51 rows. Imagine when Wikipedia only had 51 people editing per day. Kind of blows your mind. So I have their names, I have their registration date, which is in kind of a funny format. I have their current edit count, so how many edits they've made total. And this includes edits they made before January 2002 and since. And then the timestamp of a revision they made on that day. They may have made more than one revision, but I only wanted one. So the timestamp field here is a little weird. It's in a particular format. The first 4 digits are the year. The second 2 are the month. The second 2 are the third 2 are the day, and then the final 6 are hour, minute, and second. So you would see here. So we were talking about January 25th, 2002. So the first 4 digits are 2002. Then 01 for January. Then 25 for the 25th, and then in the 13th hour, in the 4th second of the 12th minute of the 13th hour of the 25th of January 2002, this edit was created. It's a little wonky, and it takes some time to get your head wrapped around it. But that's the way that that's the way we capture the date and time of edits in our databases. So you can also see that I can, in the query tool, I can actually sort by each of these columns, by alphabetically or by ascending or descending. So if I want to see, of all these 51 users, which one has the most total edits, I would see that Brian Dirksen does, with 95,000 edits. Of all the people who edited on that day, Brian Dirksen has made the most edits to Wikipedia.
Jonathan, we have an example question here.
Sure.
Someone is asking, can I ask through the query, computer, give me how many active accounts from IP of Taiwan that edited Chinese Wikipedia last month?
Say that again.
The query that this user has is, computer, give me how many active accounts from IP of Taiwan edited Chinese Wikipedia in the last month.
So we that particular piece of information we can't get because we do not share the IP addresses of registered users. When I make an edit logged into my user account, the IP address that I'm editing from here in Seattle is captured in the production databases. That information is captured, but it's not shared publicly because that's private user information. What you could do is, if you knew what the IP addresses for Taiwan were, and there are websites that contain big lists of all the which IP addresses are associated with which countries, then you could look at anonymous editors, because anonymous editors, their edits are connected to their IP address, not their user account. So you could see how many anonymous edits were made from Taiwan in a given amount of time. Was there another question, Maria?
This is a technical question, but this same user says that the text on the screen is very hard to see. Is there any way that you could enlarge the screen that you're hearing
Let's see. Is there any way for me to do that? Um, I don't. I can't think of a way at the moment.
Possibly if you change the aspect ratio of the window so that it's landscape instead of portrait, that might help.
I can also see if by... No, I'm not sure that that's helping. I'm trying to adjust my window size as well, but I don't see that having an impact. Sorry about that. Fortunately, all of these queries are queries that you can view yourself by going to the URL for each query. So you don't. So if you're having trouble seeing, a query, you can just go to this URL.
Is that query 290?
This is query 281. Current edit count of ancient editors.
I've been adding links to all the queries in the webinar page on Meta.
Awesome sauce. Thank you, Quiddity. All right, I'm going to switch back to presentation. Keep interrupting me though, because it's going to be more useful if we get if we clarify these things kind of as we go, I think. And we're back. So joining tables is one of the awesome things about relational databases. You can find out information about people and pages and categories and everything by connecting the data in one table to another table. You can also join more than two tables. In fact, you can technically join as many tables as there are. And this is useful when you want to get when you have a more complex question. So for instance, if I wanted to get the titles of all the pages in the category oral hygiene that need citations, I need information that's stored in at least 3 different tables. I need information that's stored in the page table, page title. I need information from the category table, which contains a list of which pages are in each category. And then I need information from the template table, because the template table tells me which pages particular templates are transcluded into. And in this case, we want the citation needed template. Also, all of these 3 tables have a common key. So the CL from field contains the title of a page that links to the category. Ditto with the TL from field, that contains the text or the title of a page that transcludes a template. Or rather, excuse me, these contain the ID, the numeric ID of the page, and then the page table has the page ID, a numeric ID for each individual page. So if we go to query 282, we go to query 282. So this is a more complex query, and you see that I'm joining. I'm using the word join several times. So I say the name of the table. I start with I'm starting with give me page title. So select page title, because the information I want is going to be the title of some pages. So the first thing after your select statement in a MySQL query is the data that you want to be returned. And I want that information from the page table, But I also want to join with these other two tables, template links and category links, in order to get the right page titles, because I only want the titles of pages that are in the category oral hygiene and that have the citation needed template on them. So I say join with category links on, and this says which of the fields in the two tables, page and category links, are going to be the same. Join on CL from the link the page that we're linking from equals page ID. So I'm saying that those two fields are the same. Where CL2, the name of the category that I'm interested in, is oral hygiene. And I'm doing the same thing with the template links table. So I'm saying I want pages that have TL title, the template title, citation needed, transcluded in them. And I'm matching the ID of the page from the page table with the ID that's listed in the list of pages that have the citation needed template in the template links table. And this gives me a nice succinct set of results. I get 11. And these are the 11 pages in that category. And there are many pages in the category, but only 11 of them have a citation needed template. So that gives you an idea of some of the power that you can get when you start joining the tables together, crossing the streams, as we say. Something else you can do. So some of the other syntax of MySQL that gives you interesting abilities is you can limit the number of results you want. So if I was going to say select username from user and just run that as a query, so that's a good query. Select username from user. That would return all of the usernames on Wikipedia, which is, I don't know, hundreds of thousands, millions of usernames. Maybe I don't want to get all of those. Maybe I only want a smaller number of usernames. In that case, I would put a limit clause in my MySQL statement and say, at the end of it, I would say limit 10. And that would mean that I would only get 10 usernames as a result. And then you can use distinct. If you know that there are going to be duplicate results in what you get, this says only give me the ones that are unique. And query 293 gives us an example of that. So in this query, what I'm asking for is I want the IP addresses of 5 editors who've recently asked questions at the tea house. So, and I know that non-editors don't have a user ID. They all have the same user ID, and that user ID is 0 because they're not registered users. So I want to get 5 different IP addresses that have the same user ID. So I know that the user text field is going to be different. So what I'm doing is I'm saying, give me 5 different user texts, 5 different user names that have the same ID, where these users have made an edit in this namespace to a page with this title, and the edit has this comment.
Quick suggestion, try reducing the size of your window a little bit. That way it'll focus down on what's available.
Let's see.
But keep it in landscape orientation. Or try the old Control plus. Yeah, there we go. That works.
Perfect. Oh, that's perfect. Yeah, that looks better even on this end. Okay, perfect. Thanks, Quiddity. So that gives me, so I've limited that to 5 results. If I remove the limit and submitted the query again, it would run for me, and it would give me 29 results. So this gives me 29 different IP addresses, and this is all of the anonymous user IP, all of the different user IP addresses for anonymous users. So these are people who are not registered, or at least not logged in, who have asked a question on the Tea House Q&A board on English Wikipedia in the last, I think recent changes is 90 days. So in the last 90 days, there have been 29 questions from IP users. And back we go to slides. So, limiting results is great. Another cool thing you can do is you can group and sort your results in the query. So remember that when we looked at the query results before, we saw that Quarry does this nice thing where it displays your results in this little table on the web page, and then you can kind of sort that up and down alphabetically or by greater or lesser value. You can do that within MySQL as well, and you can also do things like you can count up how many edits there have been to a page or by a user. You can also say, give me the most recent edit by this user, or give me the users with the largest amount of edits. And looking at query 287, so if we look at this query, so what I've asked for here is I want to get a bunch of information about edits that have been made to the page Howard Gobioff, which is a new Wikipedia page that was created during Wikimania. And I want to get the names of every user who has edited that page or its talk page, and I want to get how many edits each of those users has made. I also want to get the total number of bytes changed by each user, which means that if you add a bunch of text, you're adding a bunch of bytes. Byte is a unit of data storage, and if you're removing a bunch of text, you're also changing a bunch of bytes in the system. So if you look at the page history of any page, you'll see in red or green plus 2,000 something, minus 1,000 something. That's the total change in bytes that has been made by that edit. And I also want max revs timestamp, which means the most recent edit made by that user to that page. So I'm using a join here. I'm joining the revision table and the page table in order to get information about the individual edits and then broader information about the page, like the title. And if you look down here, I see that there have been 18 people who have, or 18 editors who have edited this page, including one IP address editor and also a bot. I have the number of edits by each person. I have the total bytes added or removed. And then I have the date of their most recent edit in that funny date-time format. So exploring this data, we can see that the person to edit this page most recently was Giant Snowman. It was Giant Snowman's only edit to the page. They added or removed 9,000 bytes. And that was yesterday, August 19th, at around 12 so that's at around noon, 12:21 and 50 seconds. And I can also see that the person who's made the most edits is Miss Anna Koval, and she's made 16 edits. And I can also see that Ms. Anna Koval has made the most substantial changes to the page, and that she edited last on the 15th of August. So this example gives you a sense of the kind of really useful information you can get about a page or pages and about an editor or editors with MySQL by using grouping statements, which allow you to say, I want this information, I want you to add up this information or count up this information, and I want you to group it by editor, or I want to group it by page, and then I want the results output like this. All right. So counting, summing, max and min, grouping by, and sorting by. There's one more example I'll show you. Working with cohorts, and this example actually wasn't working when Yuji and I tried it earlier this morning, so it would be an adventure to see if we can get it to work now. So this is where you can kind of directly replicate what Wikimetrics does, because Wikimetrics you start with a list of users, a list of usernames, a list of user IDs, and you say to Wikimetrics, please give me information about these people, the pages they've created, the edits they made, etc. And then Wikimetrics translates that into MySQL statements, queries the database, and then gives you the output. So in this query, which we are going to try to run together, oh, that's the wrong query. Well, let's make it the right query. We will work on this one together. It's going to be an adventure. Sweet. So this is not the right query. I'm just going to erase that. Just pretend you didn't see that. The cool thing about Quarry is that you can change the titles or the descriptions or the query itself, so that if you find that you make a mistake, which often happens when you're writing MySQL queries, or if you think of a better way to describe what your query is, you can do that. So this is a nice long query, and I'm not sure that we can get it. Normally, we'd be able to get it to display all in this one screen, but right now, it's since we're working with a beta tool, it's not doing that. But basically, we've seen this format before in some of our previous queries. I'm selecting rev user text, which is just username, and I'm counting rev ID, number of revisions, number of edits, from these two tables, the revision table and the page table, which have a common key. Every revision is a revision to a page, and we capture the ID of that page. And that ID is the same across these two tables. And I'm saying, I want these edits to pages that are in one of these two namespaces, namespace 4 and 5. Namespaces are like Wikipedia or help or category, and each one of them in the database has a numeric ID. And if you go to, I think certainly on English Wikipedia and probably on most and on MediaWiki.org, if you go to help:namespace or namespaces, it should have a list that shows you the namespaces that are on the wiki and then what their numeric ID is. So I'm saying I want edits by these people to pages in either the Wikipedia or the Wikipedia Talk namespace, and I want edits to pages in those namespaces that have a title like Tea House, and then I have this little % after it. And what that % is a wildcard. It basically means I want edits to pages that start with the word tea house. So that could include subpages of the page tea house / questions, for instance. And as another condition of my statement, I'm saying, and I only want the edits to these pages by users who are in this list of users. And this is the list that I had on the slides as well. It's just a list of usernames in quotes. You can use single or double quotes, surrounded by parentheses. So there's parentheses around the whole list, and each name in the list is separated by a comma. And then I want to group by, I want my results to be a list that has the username and then the total edits for that person and for each of these users. So let's run this and see if it works. It was not working before. But if it doesn't work in here, I can switch to another screen and show you the results there. This is our last example. We're just going to go a couple minutes over today. I hope that's all right. After we do this example, I'm going to sum up and then talk a little bit about what we will be doing for next time, which builds off of this.
A quick note from IRC UV says you can add arbitrary line breaks.
Yeah, I was having trouble with getting my cursor to insert within the text field UV. It was just that. It may be it's probably an easy fix. It was working before, so. All right. Well, we will quickly switch to another screen so that you can see the awesome results of this query. I have so many screens I can't even find my Hangout. There we go. All right. And this is me, and this is the other screen. So what you're seeing now is just another tool that allows you to run queries. This one's called SQL Pro. And in this tool, you'll see this is going to be fairly small, and there's probably not much I can do about it. But I'm highlighting right now a query that is equivalent to the query I just wrote. And then we are getting results. The results are here, and I'm highlighting those now. And you'll see that it's just a list of each of the usernames and then their total edits. And it's ranked by total edits, so that the person with the most edits is at the top, and the person in the list with the fewest edits is at the bottom. And so these are all the edits they've made to any page in the Wikipedia namespace that starts with T-house, and also any edits combined with any edits they've made in the Wikipedia talk namespace to a page that starts with T-house. So technical 13 is our winner, followed by Rickkeeper and iJethroBot. So if you see them, give them a bar and star. Sweet. All right. So switching back once again to slides. Nice. All right. So that's just a great example of how you can query the database directly to get the kind of information that you would get from Wikimetrics, which is not to say Wikimetrics is bad in any way. I love Wikimetrics, but I hope that this helps you understand kind of what these tools do, and how, if you find that Wikimetrics doesn't do the kind of thing you want it to do, you can take things into your own hands, and you can explore data beyond what tools like Wikimetrics or other tools that people are hosting on labs can do. You can get that directly. There's other cool stuff you can get. For instance, one query that I run a bot, HostBot, and HostBot invites new editors to the T-house. And so every day, HostBot needs to find out, well, who should I invite to the T-house? So HostBot runs a query. It's a big, long, ugly query, and unfortunately, it's not the one available on this link. But it runs a query, but I'll post it in my queries and link to it on the Wikimetrics webinar page. But basically, HostBot runs a query every day and says, computer, give me every new account that has been created within the past day where the user has made at least 10 edits to Wikipedia since they created their account. They are not a bot, and they have not yet been blocked. And it ends up, it's pretty regular. It's somewhere between 50 and 100 people a day. And those people are the people who HostBot considers for inviting to the tea house. So I've got a couple challenges up here. And again, I'll post the link to the slides themselves. They should be available on the Google event page, but I'll post them on grants:/evaluation/ library / it's on later slide.
Yeah, /library.
/Wikimedia, yeah, thanks Nick. /wikiresearch_webinars. So a couple of challenges for you if you're interested. These are queries that you can run, and if you need help, if you want help with, or if you have questions about them, you can ask on the IRC channel. Or just on the talk page of the Wikiresearch webinars. But one that I thought might be interesting, and I haven't run these myself, so I don't know the answer to them. There's a category on English Wikipedia for secret societies, articles related to secret societies, and so I thought it might be interesting to figure out which one of those articles has had the most anonymous edits in the last month. Are there people secretly editing articles about these secret societies? What kind of mischief are they getting up to? And for this challenge, for this query, you can get the answer to this in a single query. One hint I would give is to use the recent changes table, not the revision table. And that's because the recent changes table contains, they both contain the same information. Each row is an edit. But the recent changes table only contains recent edits instead of every single edit ever, which is what the revision table has. And so when you query the revision table, it often takes a very long time to get the data you want because it's querying n million lines of data, whereas the recent changes table has much less data. And the second challenge is to figure out who our biggest wiki lovers are. So specifically, I have two questions here. Each one of these would be a separate query. And you should be able to answer these based on the kinds of queries I've given as examples in this presentation. One is, who has given out the most Stroop waffles through WikiLove in the past year? And second, who are the top 10 wiki lovers of all time? Again, I haven't done either of these queries, but I know that they're possible. And these will both use the WikiLove log table, which is one of the special tables that's on English Wikipedia and may or may not be available on other Wikipedias, depending on whether they have WikiLove enabled. And that's it. We're not going to have quite as big of a gap between this session and the next session, which I think is good because I forget about half the things I know over the course of a month and have to remind myself. Our next session is going to be called Building on Wikimetrics. It's going to be next Wednesday, August 27th at the same time. There'll be updates and related information posted on Meta, Grants, Evaluation Library, Wiki Research webinars. And as well, you should check Grants Evaluation News, which is our news page for events like Groovy webinars that we put on. And in that session, what we're going to do, we will be building on Wikimetrics in the sense that Wikimetrics give you, just like Quarry, Wikimetrics give you output in terms of a table on a web page or in terms of a file, like a CSV file, that you download and then you play with. What we're going to do next time is we're going to take some of that output and we're going to match up the information that you can get from the databases with other cool stuff that you can get through APIs. For instance, you can get the text of Wikipedia pages through the API. You can pull the full text of them, and then you can search through that text for stuff. You can't do that in the database. So if you have a list of pages that you're interested in that you've pulled out of, say, Wikimetrics or out of Quarry, and you want to you want to get the text of those pages, you want to look through the text of those pages, what you need to do is you need to go through that list, and you need to query the API and retrieve the text of each of those pages and then do something with it. Another cool thing you can do is we have a page view API through stats.grok.se, and I'll post these links on the page, which tells you how many times a particular page has been viewed in a period of time. So you can use your list of pages that you're interested in, say that you got through Wikimetrics or Quarry, and then you can find out, say I have a list of pages that have been edited a lot recently. You can find out which of those pages have been viewed the most recently as well. And the glue that sticks this all together is another programming language called Python. Python is what we will use to read through a CSV file of, say, page names, and then query the API for other information related to those page names, like their page views or their page text, and then grab that information and then do stuff with it. Search through it, add things up, kick out pages from the list that we don't want anymore, etc. And we're going to be doing I'm going to write up Python scripts and kind of go through them. It's unfortunately not as easy to, there's no Quarry tool available yet for Python for running simple Python scripts against the API. But who knows, maybe UV Panda will build one for us. He's kind of amazing that way. But assuming he doesn't, we're still going to go through some Python scripts, and I'll put information on the page that will help you run these scripts yourself if you have your computer set up to run Python. And I'll teach a couple of very basic programming concepts that you see. Really, you see both of them in MySQL and in Python, but that you see more in Python. And this will hopefully get you really excited about making mischief with code on your own. So some of these links are still, I think all these links are currently up on the Wiki Research webinar page, but there's some nice practice and tutorial resources available for Python and for MySQL. And so if you're interested in exploring these more, go to Code Academy or SQL Zoo or the W3C. And there's also some exercises related to these on OpenHatch Wiki related to a series of community data science workshops that I worked on with Mako Hill, where you're using Python scripts to grab things from API and doing cool stuff like that. In the meantime, please add any links or tips you find helpful to the webinar page, and provide feedback or ask questions on the talk page, and come back to the Wikimedia-Research IRC channel at any time. A bunch of us are generally hanging out there, and we're mostly pretty nice people. And we are absolutely, whether we're nice or not, happy to help you with any coding or research questions you might have. And there's also a Wiki Research L mailing list that you can subscribe to. And you can ask questions at the evaluation portal question page. And if you have research ideas, you can create them at the Idea Lab, or just post them on the talk page. And that is it. Any questions?
I have only one comment. If you have been watching this virtual meetup, please leave a comment on the event page so we know who has been watching, just for our own evaluation purposes. We also have a survey that we posted on the event page we would like to know your feedback from these webinars. So if you want to let us know what you think, just please fill in the survey.
Yes, please. Fill out our survey. Let us know you watched. Make us feel good about ourselves. And yeah, so let's hang around for a minute or two and see if anybody posts any new questions on IRC or on the page. Oh, I should also say, if you have any feedback about Quarry specifically, so this is a new tool, and it works amazingly well. But like any software, it's it's going to be continue to be developed, and there will be bugs that show up. And if you encounter bugs with the tool, or even if you just have suggestions on how to make it better, you can post on the Wiki Research webinar page. You can hunt down UV Panda on IRC or on Wiki, and you can corner him and tell him your great idea. And you can also corner me on Wiki. I'm user jmorgan WMF, or user JT Morgan on English Wikipedia and on Meta primarily. And I'm happy to talk about the tool too. So,
Jonathan, can you remind us, please, what was the query for working with cohorts?
The query, it is here. It's query 290. It's called getting total edits to a page or pages by a list of users. And Quarry's telling me that it was killed. So one thing that happens is that sometimes with MySQL queries, they take a really long time because they're going through a lot of different data. And so sometimes if you're running a test query, your query will be killed, which just means that the server waited 10 minutes, the query hadn't finished yet, and so for performance reasons, the server just ended your query. It's no longer looking for the data. You can always try to run it again, and sometimes it'll be much quicker, and then it will deliver the data to you. And you may also, once you get more familiar with MySQL, this is not something you have to worry about too much now. You're never going to get in trouble just because your query was killed. Killed is such a harsh word. But as you get better with MySQL, there are ways of structuring a query more efficiently, so that it returns the data you want faster. And so you'll get the idea, you get a sense of, well, this is taking a really long time to run. Is there a more efficient way for me to ask for this data? And often there is. And often that will get you under the 10-minute limit, which will allow you to get the data you want with less frustration. Was there anything else, Maria?
No, nothing else. I
Sweet.
think we covered everything, yeah.
Sweet. All right. Thank you, everybody. Have a wonderful morning, noon, or night.